சொல்லிடுவேன். பட் இன்னைக்கு ஒரு 5 minutes எக்ஸ்ட்ராவே ஆயிடுச்சு. Okay, right, fine. So is my screen is visible? Students, is my screen is visible?
Yes, sir.
Okay, right, fine. So good morning, students. So today we are going to see the module number 15. Module number 15, the topic of ignition, right? So what is ignition and what are the terms will be required for the ignition and the types of ignition, right? In this particular we can see a battery ignition system, right? So before going the ignition part, right? So in last class we left uh, a term, right, that we can discuss initially, right? So last class we discussed the multi-point fuel injection system, right? So ECU also we discussed in last classes, right? So ECU, right? So in this last class we have seen what is the port injection, what is the port injection, right? In the port injection means the fuel will be sprayed right from the injector. It may be in the inlet manifold and very nearer to the opening, right? Inlet opening, right? So the spray, right? It sprays the fuel. It's very nearer to the inlet opening and it is located in the inlet manifold. It is located in the inlet manifold, right? See, you are seeing it is for a single cylinders, right? So if it is in multi-cylinder, so we located a multiple number of the injectors. We located a multiple number of injectors which is nearer to the inlet valve opening, right? Inlet valve opening, right? So this is the arrangement of a port injection multi-point fuel injection system. Port injection multi-point fuel injection system, right? So if it is we are using the throttle body injection, if it is we are using for a throttle body injection, right? So in this throttle body we have only one injector, right? We have only one injector. See, only one injector which is located at the center of the inlet manifold, right? This is the center of the inlet manifold, right? So before that inlet manifold we have a throttle body, right? This body is called a throttle body, right? This covering is called throttle body. So the fuel will be injected through the throttle body and it is supplied to all the cylinders, right? It will supply to all the cylinders, right? So this type of injection is called a throttle body injection system, right? So here we are using only one fuel injector, right? Only one fuel injector will be there, right? So the multi-point fuel injection system is basically classified into two categories, right? Basically classified into two categories, that is the two types, right? One is the D multi-point fuel injection system, that is D multi-point injection system, and one more is L multi-point fuel injection system, right? So the D injection system, that is D multi-point fuel injection system, is a manifold fuel injection system. It is a manifold fuel injection system, right? So here what is the uh, electronic fuel injection system, right? So the electronic fuel injection system is incorporated with the sensors and the control unit, ECU, right? So the multipoint D multipoint system also having, it is also a electronic injection system, electronic fuel injection system, right? So here also we have ECU, that is the control unit, right? So here we have ECU, right? It is a control unit, right? So the control unit receives the signals, right? The control units will be receives the signals from the engine and the inlet manifold, right? And the engine and the inlet manifold, and it gives the signal to the injector. Then the amount will be the amount of fuel supplies, right? The fuel air ratio is maybe vary depending upon the engine conditions, right? So this type of D multi-point fuel injection system, right? So here in this type, the vacuum inside, right, the vacuum in the intake manifold, right, the vacuum in the intake manifold is first sensed, right, the vacuum. See here, in the intake manifold, the vacuum has to be sensed, and the data will be sent to ECU, right. Then the air enters in the intake manifold. The air enters in the intake manifold. The manifold pressure is sensed, right? The manifold pressure is sensed, and it detects the vacuum amount, and it detects the vacuum amount, and it sends the information to the ECU process, ECU unit. Then the speed. Second one is the speed sensor, right? That is the RPM sensor. Here, the engine speed, right? So the speed sensor also sends the information about the engine RPM, right? Engine RPM to the ECU unit. Then the ECU sends the command, right? The ECU, that is the control unit, right? The control unit the control commands will be sent to the injector, and it will be regulate the amount of the amount of the air fuel mixture, and it is supplied to the injection, and it is applied through the injection, right. So when the injector sprays a fuel and air mixture in the intake manifold, then the mixture enters into the cylinder, right. So this is called the D. This is called the D multi-point fuel injection system, right. So as well as same, see, these two having the same, right, the same ECU process and same engine speed RPM and same the sensors, right. But here it will be called as the L, right. So L means the port fuel injection system, right. It is the port fuel injection system. So in this system, a fuel metering is regulated. Fuel metering is regulated, and regulated by the engine RPM, and the amount of actually enters the cylinder, that is air enters into the cylinder, right. So it is also called as the air mass, right, air mass, or air flow metering system, right. So here also the working is same, right. So the amount of air flow is sensed by the sensor, and the information is sent to the ECU process, and at the same time the engine speed also sends the information. The RPM sensor also sends the information to the ECU, and the ECU sends the command signal to the injector, and the injector will be regulated. The injector will be regulated, right. So here the only the airflow will be sensed, but here the airflow pressure also sensed, then the vacuum it sends, right. So these are the difference, right. Here only the airflow will be sensed, and here the vacuum will be sensed. These are the difference, right. So that is D multi-point fuel injection system and L multi-point fuel injection system, right. Then we can switch over to the next topic, the ignition, right. So generally, what is ignition? Anyone? When the ignition will take place? Anyone? Okay, great. So I already told in the working of a 4-stroke engine or a 2-stroke engine, right. So while at the end of the suction stroke, while at the end of the compression stroke, right. So the piston reaches the TDC, right. While in the compression stroke, the piston will be moves from BDC to TDC, but the piston reaches the TDC level, right. So it will reach before the TDC, then the combustion will be takes place, right. So before the compression stroke, right, before the compression stroke, the combustion will be takes place, right. So see here, right. So the always the ignition, right, always the ignition will be taking place just before the end of the compression stroke, right. Then what is the ignition, right? So for the in the SI engines, right? In the SI engines, we are using the spark plug. We are using the spark plug for the ignition purpose, right? So the combustion will be ignited, right? The combustion process is ignited by the spark between the two electrodes. The spark between the two electrodes in the spark plug. In the spark plug, there is production of the spark between the two electrodes, right? So that process is called the ignition process, right? So the ignition process is must, right? The ignition process is must added necessary energy for the starting, and it will be sustaining to burn the fuel, right? Sustaining the burn the fuel for the burning process takes place, right? When the burning will be taking place, then the ignition is a pre-request, right? Only a pre-request to the combustion, right? So once it ignite the air fuel mixture, after that the ignition will not required, right? So it is a pre-request of a combustion, right? And it is for only a small scales, right? A small scale phenomenon to take place within the specified small zone, as well as the specified small timing in the combustion chamber, timing in the combustion chamber, right? So it is ignition, right? What are the points you have to remember? So ignition, what is the ignition? Ignition means the spark will be produced between the two electrodes in the spark plug, right? That is the first point, right? So in the first point, in the SI engines, we are using the spark plug for the ignition process, right? So the spark will be producing in between the two electrodes of the spark plug, right? So when it will occur means it will occur just before the compression stroke, just before the end of the compression stroke, the ignition will be taking place, right? So uh, for the ignition, surely we need external energy. Some energy will be needed for the ignition process, right? Then it is a pre-request process for all the combustion process. Pre-request for all the combustion process, and it is a small scale phenomena, and it will be taken a specified small zone and as well as a specified time period, right? It is the ignition. And what are the energy requirements for the ignition process, right? For the spark plug, it's just below at 10 millijoules. 10 millijoule energy is required, right? It is adequate to initiate for the combustion ratio of 13 is to 1, right? So it may normally the normal fuel air ratio is 12 to 13 is to 1, right? That is the uh, 12 times the air and the 1 times the fuel, right? So that is the lean mixture, right? That is the lean mixture, right? Then when the spark is produced between the two electrodes of the spark plug, right? Two electrodes of the spark plug by the sufficient high voltage, by sufficient the high voltage, that voltage is called breakdown voltage. That breakdown is on that high voltage is called breakdown voltage, right? Then in the automotive engines, right? In the automotive engines, the spark energy tunes the 40. Okay, right. See, it is the 40 millijoules and the duration of 5 milliseconds, right? So in last slide we told a small scale of the specified small zone as well as the specified time will be given for the ignition, right? So the time here, see, so most of the automotive engines we are giving the time for the sparking is 0.5 milliseconds, and the energy will be 40 millijoules, right? 40 millijoules, right? So it is for the most of the automotive engines, but in the normal air fuel ratio of the 12 is to 1 or 13 is to 1, we are using only the 10 millijoules, right? So the spark, right? The spark is produced between the two electrodes of the spark plug, right? So at the time we have to give some sufficient voltage, sufficient high voltage. That voltage is called the breakdown voltage. Then, so what are the requirements, right? So what are the requirements of an ignition system, right? So just we can see one by one, right? So it should have the adequate and reverse of the secondary voltage, right? So most of right. See, these three you have to see, right? So it should have the adequate reverse of the secondary voltage and the ignition energy over the entire operating of the different speeds, right? Different speeds in the engine, right? Then the second one is it consumes the minimum power. It consumes the minimum power and it converted into the high energy, right? It consumes the minimum power and it will be converts into high energy spark, right? High energy spark, right? Then it should have a spark duration is minimum, right? Having the spark duration is sufficient and it established to burning of the fuel air mixture, right? Burning of the fuel air mixture for the all operating conditions, right? Then it should have the ability to produce the ignition spark, right? It have a ability to produce the ignition spark, right? Then the spark electrode, insulator surface. So these are the reasons, right? These are the reasons. Okay, right. So what is this reason means? We have to kick the bike or we have to give some self start, right? So even in the self start, only one kick or only one press, the bike will not be start at most of times, right? So why? Because in this spark plug we have some corrosion, we have some abrasions, corrosions, and the liquid fuels or the water concentration or any deposits on the spark plug, right? So while for the starting conditions, right? So it will not start means we have to replace or we have to remove the spark plug and we have to clean and we have to put and we can try to start and then it will be easily starts, right? So always it have the ability to produce the spark in the ignition, that is a spark plug, right? Sometimes the spark will not be start at the one kick, right? So due to this possibility of the reasons, it will not be take it will not produce a spark in a single start. Then the good performance at the high speed, then the longer life of the breaker point, and good starting when the breaker points in the open, slowly the crank speeds, that is the kicking speeds, then the good reproducibility and the secondary voltage rise the maximum and the adjustment of the spark advancement in the different speeds and the loads, right? So these are the requirements in the ignition systems, right? So what are the ignition requirements, right? So first we have to reverse the secondary volt secondary voltage ignition energy for the different speed and the range, the speeding range of the engine, and it will consume the minimum power and it will generate the high energy spark, right? It will consumes a minimum of energy power and it will be converts into the high energy spark and the spark duration which is sufficient to burn the fuel air mixture in all operating conditions and it is have an ability to produce the ignition spark when it will have some sun establishment, right? Then it will have a good performance at the high speeds and the longer life and at any point of starting, right? Any point of the starting and it will have the good reproducibility and the adjustment of the spark advancements. Then, so it is the battery ignition system. It is the battery ignition system, right? So in our most of the two wheelers or a car, right? So this type of ignition system will be there, right? So the starting of an engine by using the start battery ignition system, right? So here what are the main components, right? What are the main components of the battery ignition system means the first one is the battery, right? So generally we are using the two types of batteries here, right? So 6-volt battery we are using and the 12-volt battery we are using. Then we can see one by one, right? So first the component will be the battery, and the second one is the induction coil. These are the major components. I'm shading here. It is a major component, right? So battery and the ignition coil and the circuit breakers, and the circuit breaker and the condenser, distributor, right? So these five, right? So these five are the main components in the battery ignition system, right? So let we can see the one by one, right? First of all, what is battery, right? First we can discuss what are the components are there in the battery ignition system. Then we can see the working, how it can be work, right? So first we can see the components of the battery ignition system, right? So these are the major components, right? So battery, ignition coil, contact breakers, distributors, and the condensers, right? So these are the major components of the battery ignition system. So first we can see the battery, right? Generally, what is the function of the battery, right? The battery will store the electrical energy in the form of the chemical energy. When the electrical energy is required, when it is needed, then the chemical energy is converted into the electrical energy, right? So that equipment is called a battery, right? So battery means it's a function of storing the electricity, right? Storing the electricity in the form of the chemical energy, in the form of the chemical energy when it requires, right? When it is needed, then the chemical energy is converted into the electrical energy. It's converted into electrical energy, right? So this term is called a battery, right? This term is called a battery, right? Then the motorcycles, the motor vehicles, right? So we are using the lead acid batteries. We are using the lead acid batteries, right? So which is have connected in a serious manner, which is connected in a serious manner for very large one, right? But in the small vehicles, we are using only the positive and negative plates, right? So positive and negative plates, right? So these plates are the interspreted, and the plates are being immersed in the solution of the distilled sulfuric acid, distilled the sulfuric acid, and this process is called the electrolyte process. This process is called the electrolyte process, right? Then generally we are using the two batteries. So one is the 12-volt battery and the 6-volt battery, right? So for the most of conditions we are using the 12-volt battery. Why? Because it having some advantages, right? It is having some advantages, right? So in the terms 6 voltage and the 12 voltage, right? So the obviously the 12 voltage is having the high voltage, right? So considerably it is having the high voltage while comparing to the 6-volt battery, and it will transmit the equal power. It transmits the equal power, and the excessive voltage drop, the thickness, right? The thickness of the wire, the thickness of the cable, it differs, right? So for the 6-volt battery, it's needed it should be a 4 times thickness of the 12-volt battery system, 12-volt battery system. Then due to the high voltage supply, the starting will be somewhat good, so it improves the starting, and the adequate the electrical power supply, to increase the number of electrical accessories, right? For example, the horn, headlight, right? So these and all needed a battery backup, right? So instead of using the 6-volt battery, we are using the 12-volt for the modern bikes, right? Modern bikes. So why? Because it having some more advantages than the 6-volt battery, right? So first of all, what is battery? That you have to remember, right? So battery is a device or equipment, right? So battery is a device. So why we are using the battery means the battery is storing the electrical energy. Battery is storing the electrical energy in the form of the chemical energy. When the electrical energy is needed on the time, the chemical energy is directly converted into electrical energy instantaneously, right? So that term is called the battery, right? That term is called battery, right? Generally, we are using the two types of batteries. One is 6-volt battery and the 12-volt battery, right? So obviously, the 12-volt battery will have more advantages than the 6-volt battery. Then the second one, then the second one is the ignition coil. Then the second one is the ignition coil. So it is a diagram of the ignition coil, right? So what is the function of the ignition coil, right? It is to create an additive the spark, right? So when the spark will be produced, so the gap between the electrodes, the gap between the electrodes in the spark plug, right? So there the high energy of spark will be produces. High energy of spark will be produces, right? So for that the ignition coil will be used, right? So to produce the electrical spark, to produce the high energy spark by the ignition coil, right? To create the adequate spark across the gap between the spark plugs, the gap between the electrode of the spark plug at the high electrical pressure is needed. High electrical pressure is needed. So the electrical pressure is measured in the terms of the voltage, right? The electrical pressure is measured in the terms of the voltage. So normally it is 12 volt is supplied. 12 volt is supplied by the battery, and the spark will be produces, and the spark will be produces, right? So here the function of the ignition coil is to increase the voltage between the 10,000 to 15,000 volts, right? So the ignition coil function is to increase the electrical voltage, right? The electrical voltage uh, between that is 10,000 to 15,000. So although the voltage is increases at and with it is a normal running condition of in order to get a 4,000 to 5,000 voltage, right? Then the two coils are insulated here. Here you can see the two coils are insulated wire are wounded on the laminated soft core, right? It is a soft core, right? So it is the soft core, the term, right? This the soft core, right? So this soft core is a two coil insulated wire. This soft core is a two coil insulated wire is wounded over the laminated soft iron core. Soft iron core. The inner coil is called the secondary, and the outer coil is called the primary winding. Right? See, here we have two types of winding. One is the secondary winding and the primary winding, right? So inside we have a laminated soft core, right? Over that we have a secondary winding. After the secondary winding, after that we are having the one more coil, that is the primary winding. That is called the primary winding, right? Um, there are about the coil wounding. The coil winding is it's around 20,000 turns. It's around 20,000 turns, and for the primary it's around 400 turns, right? For the primary winding we have 400 turns. That is, here we having a 400 turns. That is 400 turns in the spirals, right? So 400 turns, and here it is around the 20,000. Here we are using the 20,000 turns, right? So if the voltage is passing through the primary coil is switched off at the higher voltage, right? As the higher voltage is induced in the secondary coil. If the voltage, the low voltage, right? The low voltage is passing through a primary coil is switched off, a higher voltage is induced in the secondary coil, right? Secondary coil, the increase being approximately in the same proportion of to the number of the turns of the two coil, number of turns of the two coils. The core and the windings is placed in a iron shell, right? That the iron shell is the soft laminated iron core, right? So the entire assembly is called the housed, right? The entire assembly is called the housing. The housing will be a sealed container, right? The housing, right? Here the housing, the housing will be a sealed container, right? So the primary coil, secondary coil, and the core will be inside the sealed container, right? So yeah, high tension, the high tension lead from the center of the coil carries a supply to the distributor, carries a supply to the distributor. The two small terminals, right? Here you can see a small terminals is suited either side of the high tension lead, right? High tension lead, the either side we have two small terminals, right? So one being connected to the contact breaker, one is connected to the contact breaker, and the second one is connected to the switch, second one is connected to the switch, right? So it is for the contact breaker and it is for the switch, right? So these are the setup of the ignition coil, right? Then we can see the contact breaker. What is the contact breaker, right? So it's a device, it is the device, it is making the primary circuit of the ignition coil, it makes the primary circuit of the ignition coil, and it consists of essentially a fixed metal plate, right? It's fixed metal point against in which the other metal point is brake. The second one is the brake, which is being the spring loaded pivoted arm, spring loaded pivoted arm, right? So the metal is used inversely, see the metal is used inversely one of the head side metal, one of the head side. So these are the two, right? So here one is there and here one is there. So it is located by in the inverted manner, right? Which is located in the inverted manner. So the fixed point, that is the fixed contact point, right? The fixed contact point is earthed, right? The fixed contact point is earthed by mounting on the base of the contact breaker, base of the contact breaker assembly, right? So when uh, if the contact breaker is in the touched condition, right? So the 2 points will be in the touch condition, the resistance supply will be there, right? So if the contact will be the brakes, right? If the contact will be brakes means the pivoted arm will be comes down and it will the brake will be uh, see here the brake will be disengages, right? The brake will be disengages, right? So the electrical supply will be cut off, the electrical supply will be the cut off one. Then the distributor, right? So the distributor includes the contact breaker point and the mechanism for the automatically the advancing or the retracting the spark timing, right? So depending upon the cam operations, so the see here, see the circuit breaker, the distributor, and the condenser, right? So these three will be controlled by the cam rotations, right? These three will be controlled by the cam rotations, right? So while seeing in the working principle, you can easily understand, right? So first, what is distributor? That you can see, right? So distributor includes the contact breaker point and the mechanism of the automatically advancing or the retracting the spark timing, right? So by the cam rotations, so the function of the distributor is distribute the ignition surge, right? So distribute the ignition surge to the individual spark plugs, right? If it is a multi-cylinder engine, we are using the multiple spark plugs, right? So the distribution will be there in the multiple spark plugs, right? So depending upon engines, right? If it may be a 2-cylinder engine, 4-cylinder engine, or 6-cylinder engine, right? So instead of the number of cylinders, we are using that much of the spark plug, that is the ignition plugs, right? So there we can distribute the total energy. The total energy generated by the battery and the ignition coil will be distributed, equally distributed into the different spark plugs, right? So that term is called the distributor. Then the condenser, right? So the main function of the condenser is to minimize the arcing or the pitting of the contact breaker, right? Contact breaker, and it will be intensify the spark, right? It will be intensify the spark, right? So why we are using the condenser means, if the spark will be more, if the spark will be more, it will be condensed, right? It will be condensed, then the required amount of voltage will be given to the spark plug, right? Then the intensify the spark, that also a function of the condenser. Correct. So in this class we can stop here, right? So we can see the working, right? How it will be works, right? That we can see in the next class.